Good morning, students. Today's topic is discovery of protons and properties of anode rays. Before moving on, if you like the video, please do press the like button, share and subscribe. Now, before going for the discovery of proton, let me remind you that earlier, after electricity was discovered, in the discharge ray tube, cathode rays were discovered, and J.J. Thomson, by studying the properties of particles of cathode rays, could decipher that the particles are made up of electrons, and electrons are the fundamental particles which are present in each atom. Now, atom is electrically neutral. So, electrically neutral means if it has negatively charged particles, it must also have positively charged particles which make it neutral. So, the emission of negatively charged electrons from the atoms of the gases in the discharge tube suggested that positively charged particles must also be present in them. So, Goldstein in 1886 modified the discharge tube by using a perforated cathode. If the cathode was not perforated, the rays were coming from cathode towards the anode and they were called cathode rays, and they were made up of electrons. Now, when the cathode was made perforated, before it was not perforated, the glow was seen on opposite side. But by using perforated cathode, anode rays could be observed. Holes which were made in the cathode, the rays were passing from anode towards the cathode, passing through these holes and striking this side of the glass vessel, making this side shining. So that means that some rays are coming from, seemingly from anode towards this side. So these rays were called anode rays. Now, these anode rays, the source or origin of anode rays, it is believed that when cathode rays strike the atoms of the gas present in the discharge ray tube, they knock out electrons from the atoms. When electrons are taken out, what is left is positively charged nucleus. It is believed that these positively charged particles, they are attracted towards the negatively charged cathode, and so they move in this direction. So, electrons are knocked out from the atoms when cathode rays strike them. These are residual positively charged particles which form the anode rays. Properties of anode rays. So, just like cathode rays, anode rays travel in straight line, because when an object is placed in their path, they cast a shadow of the object, showing that they travel in straight line. Then anode rays are deflected by electric and magnetic fields. When cathode rays were put in electric field, they were deflected towards the positively charged plate. Anode rays are deflected to the oppositely negatively charged plate, suggesting that anode rays are made up of positively charged particles. Similarly, in a magnetic field, the anode rays get deflected towards the south pole, showing that they are made up of positively charged particles. Then anode rays consist of material particles. They rotate a light paddle wheel placed in their path. Then the value of positive charge E on the particles constitute the anode rays depends upon the nature of the gas in the discharge tube. This is in contrary to the particles of cathode rays. They always had the same charge. But here the value is a multiple of charges. It is found to be a whole number multiple of charges on the electron, but with a positive sign. Electrons had charge equal to 1.602, but with a negative sign. These particles have charge equal to 1.602 or its multiple, but the sign is positive. Then value of E by M ratio for these positively charged particles was also calculated using the same Thomson's experiment. but this value was not constant. It depended upon the nature of gas enclosed in the discharge tape. And when the gas was hydrogen, the value of E by M was found to be maximum and was equal to 9.58 into 10 raised to power 4 coulombs per gram. The magnitude of positive charge was also found out. It was found to be same as that on the electron but with a positive sign. So this charge was 1.602 into 10 raised to power minus 19 coulombs. The mass of the positively charged particle was again calculated in the similar manner, that is by dividing charge with the charge to mass ratio. So charge is 1.602 into 10 raised to power minus 19 coulombs. Charge to mass ratio is 9.58 into 10 raised to power 4 coulombs per gram. On dividing, we get the mass equal to 1.67 into 10 raised to power minus 24 grams. The value is same as for the hydrogen atom. So a proton may be defined as a fundamental particle in an atom which carries 1 unit positive charge, 1.6 into 10 raised to power minus 19 coulomb, and 1.67 into 10 raised to power minus 24 gram mass, equal to that of a hydrogen atom, regarded as 1 unit mass. Another thing that I must tell you is that the proton is discovered by Ernest Rutherford. Though you saw that Goldstein used the modified discharge rate tube, but Goldstein could not identify or isolate positively charged particle as proton. What Goldstein found out was positively charged residual atoms left from the gas filled in the discharge tube after electrons were knocked out from them. But it was Ernest Rutherford who could ascertain that each residual atom consists of a number of positively charged particles. So if you are asked who discovered proton, it is Ernest Rutherford.